Hi. So previously we discussed the preference relations, and today in this video we'll try to further define the utility functions based on the definitions that we have previously on the preference relations. Okay. So normally in microeconomics we normally use the utility functions, right, instead of the preference relations. Those are not very convenient for us to calculate the numbers, right? So how do we define those utility functions? So utility functions are just the functions that assign some numerical values or some real numbers to each element in the set of alternatives x, right? So it ranks the elements in x according to the individual's preferences. Okay. So that assigns, let's say, a real number to each element in set of alternatives x. Okay. And that reflects the individual's preferences. Okay. Good. So, and be careful that this utility functions are normally defined as some ordinal functions or ordinal reveals ordinal properties. It's not cardinal. Okay. So it means that those utility functions reflect the relative positions or the relations between each alternatives, right? Elements in the set of alternatives, and it doesn't tell us how much of the difference between any of the pairs, right? So we cannot compare across the differences of those alternatives, since there will be no meaning of that because we simply rank all the alternatives in the preference relation, and here similarly using this utility function to define analogously to that, right? Okay, so now let's make a rigorous definition. So this will be the definition in the textbook 1.b.2. So let's say a function, okay, a function u, okay. So it's from set of alternative x, and it maps to some real number, and this is called a utility function. Okay, and it represents or representing preference relation, this, right, if you recall from the previous video. And so when it can represent this, if for all little x, y in x, if we have x is weakly preferred to y, then this implies, or no, if and only if the utility of x is greater than or equal to that of y. Okay. So because here we are comparing to real numbers. Okay, so and here we could immediately observe that this utility function it is not unique, right? And we could simply make some transformations, and they still keep this ordinal rankings, right? So you can simply plus something or multiply by something, as long as you do not change the order of those alternatives, right? Okay, so and some comments. This utility function representing some preference relation, this u is not, so this utility function is not unique, as we just said, right? So, and it turns out that for any strictly increasing function, strictly increasing or monotonic transformation f from real to real. Okay, so let's see, call this v of x, and it will be some transformation f of the original ux. So this new utility function, okay, it still represents the same preferences as you did, okay? Represents the same preference as u does, okay? Good. And only the ranking or the order of the alternatives matters, okay? Good. So those are called by the strictly increasing transformation, and the properties, they do not change. This is called ordinal, okay? And the other kind of property called cardinal, if those properties, they're not preserved by those kind of transformations, okay? Good. All right, so that'll be the definition. So now let's move on to some results of the utility functions, a very, very fundamental result. So that'll be the proposition 1.b.2. Okay, so it says that some preference relation okay, so this preference relation, it can, when this can be represented by some utility function, right? Sometimes we cannot, okay? So this can be represented by a utility function okay, so here the result is that if a preference relation, it can be represented by a utility function, then we have then this preference relation, it has to be rational, okay? Good. So how do we prove this result or this proposition? Okay, so simply we need to show that if there exists some utility function that represents the preference relation, then this preference relation, it has to be complete and transitive. Okay, so we simply prove by two parts, complete and transitive, right? Okay, good. So now let's start the proof. So first one will be the completeness. Okay, completeness. So now we suppose that u is already some real value function defined on x, right? And then we want to show that this preference relation, it is complete. Okay. Okay, so how do we show that? So we simply, as we just said, so given that the sum u is some real value function, okay, so because u is a real valued function defined on x, right? It must be that for any elements xy in big X, okay, so we can always compare two real numbers. Okay, so it means that we can either have ux is greater than or equal to uy, or the other way around, right? So real number is complete. Okay, or ux. Okay. So because since u is a function representing the preference relation, so this above result in the last paragraph, so that implies either x weakly prefer to y, or y weakly prefer to x, right? And then this gives us the completeness. Okay, good. So that'll be the first part. How about the transitivity? Okay. So it'll be following the similar approach, right? So for the transitivity, and now let's suppose that x is weakly preferred to y, y weakly preferred to z. Okay, and because u is representing the relation, right? So we must have ux greater or equal to uy, uy greater than or equal to uz. Okay, so the real numbers have the transitivity, right? So ux must be greater than or equal to uz. Okay, and again, because u represents that, so x is weakly preferred to z. Okay, and we start from this and we end up with this. So it means that the transitivity is proved. Okay, good. So this completes the proof for this result. So again, this result states that if some preference relation, it can be represented by a utility function, then this preference relation, it has to be complete and transitive. So it has to be rational. Okay. Good. So just make sure that it says this way, okay, not the other way around. So and we want to ask that, can any rational preference relation, so can any of those relations just be described by some utility function? And in general, and if you already see the textbook, and in general the answer is no. Okay, so we cannot always use some utility function to describe the preference relation. Okay, so and you can see some examples, and when it's not possible in the later section 3.g, and one of the cases would be that so we can always, it turns out that we can always represent a rational preference relation, okay, with a utility function when this set of alternative is finite. Okay, good. If that is not finite, then we cannot always represent a rational preference relation with some utility function. Okay, good. So those would be just some special cases, and if you're interested in those things, then you can always refer to the textbook and have some further reading on that. Okay, good. So this completes the definition and then some result for the utility function, and later we'll introduce some the other approach, right, called a choice-based approach that we discussed in the beginning of this series, and compare those two different approaches. Okay, good.